Hello. Today we are going to tackle this problem, water and jug problem. You are given two. Okay, let's read the description. You are given two jugs with capacities X and Y liters. There is an infinite amount of water supply available. You need to determine whether it is possible to measure exactly the liters using these two jugs. If z liters of water is measurable, you must have z liters of water contained with one or both bucket by the end. Operations allowed. Fill any of the jugs completely with water. Empty any of the jugs. Pour water from one jug to another till other jug is completely full, or the first jug itself is empty. Well, it's okay. Here's an example. So 1 liter has volume 3, and another have volume 4, and the z is we can use 3 and 5 to get a 4. So how does it work? If we can think of the 3 and 5, can we get a 4? So in this case, we notice if we fill up 4 and then pour the 4 or 5 to 3, and then so in the 5 liter bottle we have a 4. We have a 3. We have a 5 minus 3 equals 2. So in this, or in the 5 liter bottle, we have a volume 2, and since we can get one volume 2, and we can definitely multiply it. So from 3 and 5 we can get a 2, and we can, since we can get 1, 2, and the amount is unlimited, then we can also get 4, right? We just repeat this process twice and we can get a 4. And since we can get a 4, we can definitely repeat the process 3 times, and then we get a 6, and so on and so forth. We repeat the process 4 times, we get an 8. So here z equals to 2, 4, 6, 8 are all valid, they're all true. And the next one is 2, 8, and 5. So initially, if we for both, we can get 2 and 8, 2, 6. So if okay, let's see if we have other combination. So what we have is if we fill the 6 and pour 2, and then in this 6 liter volume jug we get 4, and we notice this 4 is new, it's not 2 or 6, and since we can, so this is the process 1. If we only do this process 1, we can get a volume 4, and if we repeat the process twice, then we can get an 8. So initially we only have 2 and 6, and now if you repeat this process, you can get the multiplier of the 4. For example, here, if the z is 4 or 8 or is 12 or 16, these are all true. So as long as we get this understood, I think the code should be easy. So the magic trick here really is how do we get this 2? For example, here the original GeoGra 3 and 5, and we get a 2, and we can multiply it and compare the product with this z. And in the second example, we have the 2 and the 6, and from these two volumes we can get the magic number 4. So this is process 1, and then we can get multiple 4s, right? We can get 4, 8, 12, 16, and then these are the new numbers we can get. Then we compare these numbers with the 5. So okay, now let's look at the code. First we consider the edge cases. If the z is below 0 or z is bigger than the sum of x and y, then we return false. This means if I fail bottom 1 and I fail bottom 2, but I still cannot get this z. For example, in this case, if z is 100, then we definitely return false, right? This is due to the restriction here, one or both buckets to the end. Okay, now it's time to get this magic number. So we can here okay, we use a helper function to do that for us. So here x and y, we have x. Okay, let's use okay, how to say okay, here's an example. Suppose the volume is 15 and 4, and we want to see if we can get 11. Okay, so here 11 actually don't matter. We just want to get we want to get this magic number first, or the base first. So we first fill this we can fill this 15 volume, and then get the mod of 4, and then we get the mod is 3. So how do I say well, okay, so if we are not allowed to pour the bottles over and over, then we only have 15 and 4. But since we can pour the numbers, we can pour the 2 bottles together, then we have some extra volume, and this extra volume is 3. So what does this 3 mean? That can imagine this logically. So first you fill up the 15, and then you pour to the 4. So the 14-liter bottle now only have 11, and then you minus 4, right? You pour out the water, so you get 7, and then you still use you still deduct the volume from the 15, and so 7 minus 4, you get 3. So that is what does this 3 means in the physical. So this means from 15 to 4 we can get 3. Then we can so, and then we call this function again. Now we have the 4 and the 3, and we want to see since we can get this 3, then we want to repeat the process. Then we get the minimum. We want to get the minimum volume. For example, here it's 4, and I can before I only have 15 and 4. I can get a 3. Now I have 4 and 3, and so from 4 and 3 we repeat the process. Then we get 1. This means you first fill out the 4 liter, and then you pour the 3 liters out. Then you have 1, and after you get the 1, then you can get any multipliers of 1. For example, you can get 1 plus 1, or 1 multiplied by 2. So, and then can keep multiplying, and these are all the valid answers. For example, in the code, in this example, you have 15 and 4, and run it. You can see the minimum possible. The minimum possible number is 1. So from this 1, you can use the z to check if we can multiply the process again and again to get this z. Yeah, it is a little difficult to understand, but I would say from the first process you really need to know what is the minimum possible number here, and then you just keep multiplying the processes and check if you can get the z. Yeah, that's all.